Hello viewers of mine, this is a What the Physics video going over Graphing 101. Specifically, this worksheet is referred to as Excel Graphing 101, but you know what? That's what it was called when my buddy, Mr. Writer, first started it. That was back with Excel 2013. Let me tell you, Excel's changed a few times. So I had to do updates for Excel 7 and Office 365, and finally I've done an update for Google Sheets. So we're going to focus on the Google Sheets update today. So what we've got here is a set of data, and it says extension on this column here. This first column, by the way, always goes for the x-axis or the horizontal axis. The second column always goes for the y-axis or the vertical. In this case, what the lab would have consisted of, if we had actually done this, is we have a spring hanging vertically, and it's hanging from some particular position, and we start adding on weights to the bottom end, and as we add on the varying amounts of weight, we see how much the spring will stretch. So that's the extension. So this is actually a legit physics lab, and it introduces us to Hooke's law. We're not going to go into that anymore, really, other than maybe talking about IV and DV. But what I want to do is say, hey, let's say we've got this data. What am I going to do with it? Well, I want to make a graph out of it. So what am I going to do? I'm going to go, move this out of the way. I'm going to go to Google Sheets. So you go to Google Sheets, and I just already entered all the information right there. And then once I enter it, I want to select this data. I'm going to highlight it, and I'm going to make a graph by clicking on Insert, and I insert a chart. Now, why do they call it chart instead of graph? I don't know, but they just do. So go ahead and insert a chart. And what this does is it is going to go ahead and create a graph or chart based on the highlighted information. And this is really nice because let's scroll a little bit there. Okay, I'll need to adjust the sizing here. There. So it's really great because as you can see, as we mentioned, this one is for the X or the horizontal. It went ahead and automatically put in this information on the axes. It labeled the axes and put in the units. And then it's also got a title, your standard Y versus X title. So that's really lovely. This here is the graph, or as they say, chart. This is in particular is called a scatter chart, scatter graph. Now there's all sorts of ones that might have popped up. Most of the time when it's data points like this, Sheets is able to figure out what you're looking for, but I've never actually had a pie chart show up like this. But if it did, all you'd have to do is go into Setup, and then you choose what type of chart you have. And as we see, it's scatter. Wonderful. You don't really have to do anything else in the Setup category. Next, pop over to Customize. We'll spend a lot more time in Customize. Now, there's a few areas that we might have to deal with, but most of the time we'll spend it in series. But let's take care of those few areas first. If for some reason the titles are not here, then we could go ahead and get into this and change that up. And then here, let's close that. And then we could also go into the horizontal and vertical axes and adjust things there. And actually, I do want to adjust something in the horizontal axis. See how this starts for some reason at 0.01. You know what? I want it to start at 0. So I'm going to put in a minimum value right here. And it automatically shifts it over for me. And you're like, oh, great. And I only had 5 data points, and it's still visible. The maximum is still visible. So I don't have to adjust anything here. I could, and I'm just going to keep all these other things the same. I could do a similar thing for the vertical axis, although that's already from starting at 0, and we're already able to see those. So I'm going to close up the vertical axis. As I mentioned, I'm going to spend most of my time in here in the series section. Series section. Now, why didn't they call it something like analyze? I have no idea, but that's what it is. for as helpful as Google Sheets is in doing a lot of the work for you, they still sure do have a weird naming system. So let's go ahead and do a trend line, which we would call the line of best fit, or the LOBF. So trend line, you say, oh, lovely, lovely, lovely. Looks like a nice straight line. Great, and it is because that's how we chose it, a linear. You can also choose other ones here. This video I'm making for my General Physics 1 class. If I were making it for my honors or AP or something, I'd go ahead and explain how you could actually do a power series fit. In this case, because the data is linear, it wouldn't really change much other than when I go ahead and put up the when I go ahead and put up the equation. But I'm just going to keep it as linear right now. So let's see. So the label is where I'm going to have the equation. So it says use equation. And I've got that. And look at this. It's trying its best to do like a y equals mx plus b, because that's a linear relationship. Notice it actually changed the y into weight. And then it kind of looks like an equal sign. And then there's the m, that 19.1. And then the x, and then the plus b, the y-intercept. Great. Except that is not how we express things in physics world. In physics world, we no longer have a y-axis. We don't have an x-axis. You say, what? Instead of a y-axis, we have weight. Instead of the x-axis, we have extension, or whatever it is that happens to be on the horizontal and vertical axis. So what I got to do is I've got to get this information because these numbers are legit. So what I'm going to do is I'm going to double click, maybe triple click. Hello? Okay. And it's supposed to be able to select that. It usually does without any issue. But you know what? That's fine. I will just be able to type it off to the side here. So I'm going to type these numbers in that are here. I'm just going to put it in the cell. So that's going to be, so I activated that cell, 19.1. And then I'll put in the time to x, although I will change that in just a few. And then we've got a plus 0.0112. So like I said, it's weird. I can usually just select that, but okay. And I'm going to copy this. So Control C, and then I'm going to put it into where I was just pointing out. And you say, oh no, where did that information go? Oh no, double click. Just go over here and double click, and it comes back. Yay. So we go back to series, and now we're still in trend line and we still have linear. And now I'm going to go from use equation to custom. Okay, notice it changed it to trend line for weight, which doesn't really tell us anything useful. So what I'm going to do is I'm going to substitute in the equation there. Now the equation, I suppose, to make it an equation, I do need something equals something else. So there's my equation in y equals mx plus b form. But here's the thing. In physics, we don't deal with y equals mx plus b. I've got to change my y-axis to weight. You say, wait for what? No, I'm changing the y letter to the unit, or to the concept of weight, and I'm also putting in the units in there too. And then I will also do the same thing for the x-axis, although just to make it a little more obvious, I'm going to put parentheses around there. So that's going to be extension in meters. Oops, jump to the end for some reason. M. Okay. Now, I also need units with this guy, 19.1, because that's the slope. We know that from y equals mx plus b, m is the slope. But what we haven't really emphasized much in math class, as we will in physics class, is that all of these really have a meaning. So the slope is a relationship between what's going on the y and what's going on the x. So I need to incorporate the units from the y and the x. So unit on the y-axis, or the weight axis, is newtons. So let me go ahead and I'm going to keep the number 19.1. That's lovely. But I'm going to put in 19.1 newtons divided by meters.
Good afternoon, Senator.
Okay, that was a little announcements from beyond there. Let me go ahead and put in the closed parentheses. And then finally, I'm going to put in one more set of units here. The units for the y-intercept are the units for the y-axis. So I'm just going to put in newtons. Okay, and notice that does it all right here. Okay, so the final thing that I want to do, I'm going to go back here, and I'm going to put some spaces right at the very end of this. Now, you don't see anything going on up here. That's fine, because I'm going to add in something. I'm going to add in the show r squared. So by showing r squared, without getting into, well, any real detail at all, you want your r squared value as close to 1.00 as possible. Technically, it can range from 0 to 1.00. 0.994 is really, really awesome. This data is great. It just means how well the data points fit with this particular trend line. So as you can see, it fits very, very nicely. So just to make sure that we understand what we've done, we've taken our data and put it in. We've typed it in here. You use the first row of each column to label the data that you have. So in this case, for the x-axis, which we're calling the horizontal axis now, is extension, and the y-axis, or the vertical, is weight. And I put in the numbers. Oh, and I also put in the units there too. Okay, and I had those selected, and then I clicked on insert, and I would press on chart. Okay, so I won't do that right now because I've already got my chart. And this comes up. Now, it didn't have the line of best fit or the equation, but that was easy enough to put in. You say, oh no, where did that information go here? Oh yeah, we double click. We just got to make the chart or graph active. Okay, setup was only used if we needed to change what type of chart it was. Sometimes it might come up as a different chart, but usually it comes up as scatter. And then most of the time we spend in customize. So let's see, customize allowed us to do, well, let me get rid of this. So we spent most of our time in series. If necessary, you can go to the titles and adjust the title, although Y versus X is what we're looking for. And then you can also go into horizontal axis if you need to adjust the scaling. Okay, most of the time we do want to start from 0. So in this case, we put in 0 for the minimum. We didn't need to adjust the maximum. And then you can do likewise for the vertical. Okay. Didn't need to, but you could. Okay. And then, as we said, most of the time is spent in series. Okay. This is already a linear data set, so I just left it as linear. For linearization, you can go into the more complex by changing up to a power series. I have a different video for that. And then you go ahead and change the label to use equation. I won't do that because that'll make things disappear. But then it'll say what the equation is up here, and I just had to put it, type it in here to keep track of it. Usually I'm able to copy and paste it into the custom. I paste it in here. I change so it's in a physics format instead of a math format. So instead of y is equal to mx plus b, I change it to the y variable, the vertical variable with units, equals the slope numerical value, which was given, and then the units for the slope, and then the concept, the variable concept for the horizontal axis with units, and then finally I put in the units for the y-intercept, which are the units for the y-axis. And I also clicked on the show r squared. Good stuff. Physics. I did want to add on one little piece of information when it has to go along with the where do you put your independent variable and your dependent variable. Quite often we say independent variable goes on the x and dependent variable goes on the y. That's for kind of the more basic levels of science, but I did want to touch on a little point here. It's not always going to be like that. It kind of depends on what we're getting at, what we're looking at for the ratio, because as we said, the slope and stuff is super important. That has actual physics meanings. So as I had said, the experiment here was we kept adding on weights and we saw how much the spring stretched out. So that means the weight was really the independent variable and the extension was the dependent variable. You say, whoa, hold on a second. Independent variable goes on the x, son. Well, not in this case, because what we want to get from here, and actually we did get from here, was the equation known as Hooke's law, which is equal to force is equal to K, which is the spring coefficient, which is this guy right here, times the stretch distance. Okay, that is Hooke's law. That is a well-known equation in physics. So we had to set it up that way. We didn't put the independent variable on the x because we were looking for a particular relationship. So most of the time, yeah, you'll put your independent variable on the x, but a lot of the times you won't, simply because you are looking for a particular relationship. Also, if you're dealing with time, time usually goes on the horizontal axis, but that's not the case here.